Hello everyone, my name is Saloni and today we'll discuss a question that will be helpful to you for all physics competitive exams. Question is that current in a Crookes tube is 10 nanoampere. How much electrons strike the face of the glass tube each second? So basically you're given I which is equal to 10 nanoampere. Okay, and you know what is I? I is total charge divided by total time. Okay, which you can write here is number of electrons, total number of electrons into E divided by T, right? And N by T, this we have to calculate in our question, okay? Number of electrons striking the face of the tube per second into E. So N by T, how you will find? You do this 10 nanoampere divided by E, okay? So what is 10 nanoampere? 1 nanoampere is of course 10 to the power minus 9 into electron into this E, which is 1.6 into 10 to the power. This is the charge on an electron. Okay, so when you solve this, you get 6.3 into 10 to the power 10. Okay, because this will go upward. This will be minus 9 plus 19, and this will be 10 by 1.6, which is 6.3. So this will be 6.3 into 10 to the power 10 seconds inverse. Okay, because n is number and t is time. Okay, so this is our answer. So our next question says that the electron in a cathode ray beam passes between 2.5 centimeter long parallel plate electrodes that are 5 centimeters apart. A 2 millitesla, so this is 10 to the power minus 3 Tesla, 2.5 centimeter wide magnetic field is perpendicular to electric field. The electron passes through without being deflected. If the potential difference is this, what is the electron speed? Okay, so when you do these type of questions and you know when will uh, like there'll be no deflection, we know that v at that time is equal to E by B. Okay, and you know that electric field, this is in our question we are given potential difference, so electric field will be delta V divided by d into B. Okay, so delta V in our question is given as 600, right? Right, and in our question D is the distance. Okay, when which in our question is given as 5 millimeter apart. We are given that parallel plate electrodes are 5 millimeter apart, which will be equal to 5 into 10 to the power minus 3 into magnetic field. What is magnetic field? It's 2 millitesla. So this is 2 into 10 to the power minus 3. Okay. So when you solve this whole thing, you get 6 into 10 to the power 7 meter per second. So this is the velocity with which it will come out undeflected electron. If the potential difference between the plates is set to 0, what is the electron radius of curvature? See, when delta V basically, this is velocity basically here, okay? Velocity or speed, basically speed. Okay. In the second part, we are given that this delta V becomes 0, which means that there is no electric field. And if there is no electric field, then definitely because there is magnetic field, because there is B and there is some speed, so our electron will move in a circular path. Okay. See, the electron plate is set to 0. Now at 0 we have our speed also, but and we are given that it is perpendicular. Okay, so our velocity is of course in the direction of electric field and our magnetic field is perpendicular. So basically in our question now it's given that there is no electric field, there is some velocity, and you can say that this is like our magnetic field. Okay, in these kind of questions you know that what we use is BQV. This is the force which is equal to centripetal force. Okay, right, so we have to calculate radius of curvature. So R will be here mv square divided by bqv is equal to mv divided by bq. Okay, so R here will be mv by bq. Okay, so you can solve this is here. R is equal to mv by bq. M is the mass of the electron, which is, you know, it's 9.11 into 10 to the power minus 31. What is the speed? We have already calculated. It's 6 into 10 to the power 7 divided by B. In question it's given 2 into 10 to the power minus 3 into Q. We know what is the charge on electron. It's 1.6 into 10 to the power minus 19. Okay, and when you solve this whole thing you get 0.17 meter, or you can write it as 17 centimeters. So this is the radius of the circle in which our electron will move now when electric field is set to 0. Okay. So next question says that the electron pass through parallel electrodes in figure with this speed. Okay, so the speed is given to us. What magnetic field strength and direction will allow electrons to pass through without being deflected? We know if we want no deflection, V is equal to E by B. Okay, assume magnetic field is confined to the region. Okay, so between the electrodes we have magnetic field, and so we simply what have to find? We have to find the magnetic field. So what will be the magnetic field? It will be E by V. Okay, and you can see that this is the potential difference here. So this basically you can write B is equal to electric field is delta V by D into V, which is the velocity here. Here this V is potential difference, right? So in our question you can see that our potential difference is given as 200 volts. So this is 200 volts divided by the distance. Okay, so what is the distance between? It's 8 millimeters. Okay, so it is 8 into 10 to the power minus 3, and in our question the velocity is given as 5 into 10 to the power 6. Okay, so when we solve this whole thing we get 5. So we solve this 5 into 10 to the power minus 3 Tesla. Okay, so this is our magnetic field. Okay, and if you want to know the direction, you can simply see that this is plus, this is negative. Okay, so this is our electric field, and when this electron enters, okay, so electric field, because of this electric field our uh, this electric field our force will be upward, because for electron the force will be equal to minus E into E. So the direction of force will be negative of what will be the direction of electric field, in the opposite direction. So F is upward, so you want magnetic field to go magnet force due to magnetic field to go downward. Now you have this as your electron. Okay, so if you take this as your magnetic field and then you use your uh, right hand rule, okay, we know that F is equal to will be equal to minus E V cross B. Okay, so this is V. So you do V cross B. If you do V, if you apply the rule here, right hand rule, and you do V cross B, then our force will be like the resultant of this will be downward, and because there is minus, the resultant will be upwards. So definitely this we want our force to be downward. If we are taking magnetic field inside, then we are getting our force to be upward. So to cancel out the force due to electric field, we want our force due to magnetic field downward. So from here you can justify that yes, it will be the direction of magnetic field will be this. That means out of page. Okay, so that means out of page. Okay, so our next question says that there is an air droplet with 15 excess electrons is observed between two parallel electrodes spaced 12 millimeter apart. So the distance between electrodes is given as 12 millimeters. Okay, and we are given 15 excess electrons. So we know that this is 15E. The charge is 15E, and it's also negative because there are excess of. So you can write if E is the if E is the magnitude, then you can write minus 15 E. Okay, so Q is this negative. The charge is negative. Okay, the droplet hangs motionless. The upper electrode is 25 volt more positive than the lower electrode. The density of the oil is this. What is the radius of the droplet? Okay, so how you do this question? So this is our droplet. Okay, this is basically positive charge. You wait. Okay, so this is our positive charge, and this is our negative charge, and this is the electric field. Okay, it hangs motionless, so that means basically this is mg and this is f. This is 25 volt. We are given that this from this potential, this is more 25. So the difference delta V is 25 volts here. Okay. And of course, electric field is this side and this charge is negative, so force will be this side. So you can apparently see that F is equal to the F, both F and mg are in opposite direction. So what you have to do is F is equal to mg, and what will be F? F is equal to Q into E is equal to mg. Now mg you can write as density into 4 by 3 pi r cube into g. Okay. So from here and here you can write E you can write as, so E you can write as delta V by D, the change in voltage divided by the distance between those electrodes. Okay, and this is 4 pi r cube rho into G. So from here R cube is equal to delta V by D. This is 15E divided by, this is 4 by pi rho G. Okay. So you put all the values. This is 25, this is 15, this is 1.6 into 10 to the power minus 19. Okay. Of course, here because we are just equating magnitude, we don't have to take Q as negative value. Simply take the magnitude of it. What is D? D is, of course, it's 12 millimeters, so it will be 0.012 into 4 3 pi into this is 816. Question is given 816. This is 9.8. Okay, so you calculate this whole thing. When you calculate this, r cube comes out as r cube comes out as 1.4163 into 10 to the power minus 19 meter cube. Okay, and when you do the cube root from here, you get r equals if you do the cube root, you get 0.52 into 10 to the power minus 6 meters, which is actually equal to 0.52 micrometers. So here you can you have calculated that the radius of our droplet comes out to be 0.52 micrometers. Okay, the next question says determine the speed of a 100 electron volt electron. Okay. So A part is speed of 100 electron volt electron. Second is speed of a 5 MeV neutron. Third is specific type of particle that has 2.09 mega electron volt of kinetic energy when moving with this particular speed. Okay, so first part when we solve this is speed of a 100 electron volt electron. Yeah. Simply, you know what 100 electron volt, this is the kinetic energy, so you convert into one electron volt is 1.6 into 10 to the power 19 joules. So this is basically energy. So this you get 1.6 into 10 to the power minus 17 joule. Okay, now this is the kinetic energy. Now, so kinetic energy is equal to 1.6 into 10 to the power minus 17 joule. And you know kinetic energy is half mv square. We put it equal, and we are given that this is electron, so we know the mass of electron is 9.11 into 10 to the power minus 31 kg. Okay, simply put it, so v square is equal to 2 into 1.6 into 10 to the power minus 17 divided by mass, which is equal to 9.11 into 10 to the power minus 31. Okay, we solve this, you get when you solve this whole thing and do the under root. So let me show this here. We solve this thing and do the under root. 2 into 1.6 into 10 to the power minus 17 divided by 9.11 into 10 to the power minus 31. This comes out as 5.9 into 10 to the power 6 meter per second. Okay, so this is how you solve the first part. Okay. Similarly, how to do the second part? We are saying it's a speed of 5 mega electron volt neutron. Okay, speed of 5 mega electron. Our next question says determine the speed of a 6 mega electron volt proton, speed of a 20 mega electron volt helium atom, and the specific type of particle that has 1.14 kilo electron volt of kinetic energy when moving with this particular speed. So for solving the first part, simply we know that kinetic energy is half mv square. Okay, so simply put this as 6 into 1.6 into 10 to the power minus 19, and this is mega, so this is 10 to the power 6 you multiply it, and this is 1 electron volt is equal to, we know mass of proton is 1.67 into 10 to the power minus 27. Okay, kg, and v, you put it v square. Okay, now you write this as v square. So you can write as v square, you do the under root, you get 2 into this 6 into 1.6 will be equal to 9.6, and this is 10 to the power 6, 10 to the power minus 90, this is 10 to the power 13. Okay, so 2 into 9.6 into 10 to the power minus 13 divided by the mass of proton. Okay, so we use solve, we get this as 3.4 into 10 to the power 7 meter per second. Okay, so this is how we solve the first part. Second part is the speed of 20 mega electron volt helium atom. Okay, so in helium atom, of course, the mass of electrons are neglected because it's very small compared to our mass of proton. So simply again, k is equal to half mv square. So v is equal to basically under root 2k by m. So v is equal to 2 into, we are given 20 mega electron volts. So this is 10 to the power 6 into 1.6 into 10 to the power minus 19 divided by 4 into, because we know that it's there are 2 protons and 2 neutrons in helium nuclei. Okay, so this is, you do this, you calculate this whole thing, and finally your answer comes out as 3.1 into 10 to the power 7 meter per second. Okay, our next part says the specific type of particle that has this much energy when moving with this particular speed. So you're given, and you're given but no mass, because uh, that is basically dependent on the particle, which particle you are choosing. So of course it's an unknown particle, so we'll calculate the mass and then we'll see which particle has that particular mass. Okay, so simply what you do is k is equal to half mv square. From here, m is equal to 2k by v square. M is equal to 2 into, what is the kinetic energy that is given? 1.14, and speed is given 2 into 10 to the power 7. So this is 1.14 kilo electron volt. So this is 10 to the power 3 into 1.6 into 10 to the power minus 19 divided by velocity square, which is 2 into 10 to the power 7 whole square. So when you solve this whole thing, you get 9.12 into 10 to the power minus 31 kg. Okay, and from here you can simply see that this is nothing, very close to the mass of electron. Okay, you take mass of electron as 9.11, this is 9.12, it's almost same. So this is nothing but the unknown particle is electron here. Okay, our next question says the kinetic energy of an electron moving with this particular speed, the potential energy of electron and proton. So this is A part, this is B part, and this is C part. So we're given the kinetic energy of an electron moving with speed this. the potential energy of an electron. The first is kinetic energy of electron moving with this speed, potential energy of electron, which is this much apart. So let's do the first A part first of all. Okay. And third part is kinetic energy of proton that has accelerated from rest through a potential difference of this. So first we'll do the first part. First of all, kinetic energy of an electron. Okay, so this is half into, we know mass of electron is 9.11 into 10 to the power minus 31 into velocity were given 5 into 10 to the power 6 whole square. Okay, when you solve this whole thing, you get your energy as 1.139 into 10 to the power minus 17, minus 27. This is, this correction, this is 17. Okay, this is 17. So this is 1.139 into 10 to the power minus 17 joule. Okay. Okay, so this is the kinetic energy. If you want to calculate this kinetic energy into electron volts, what you have to do? You have to simply divide by 1.6 into 10 to the power 19 to get it into electron volts. And when it's converted, this comes at 71 electron volts. Okay. Next is B part. It says the potential energy of electron and proton which are these much distance apart. So you know the potential energy formula between two charges is K Q1 Q2 divided by R. So the charge of proton is plus E, the charge of our electron is minus E divided by R. Okay, so you put K value, which is, so this is minus 9 into 10 to the power 9. Okay, this is, of course, this will be E square, so 1.6 into 10 to the power minus 19 whole square. And what is this R? R in the question it's given as 0.1 nanometer. So this is actually 0.1 into 10 to the power minus 9. Okay, so you solve this whole thing, you get minus 2.3 into 10 to the power minus 18 joule. Okay, so this is the potential energy. If you want to calculate this energy in terms of electron volt, simply divide by E. Okay, so let me calculate that. So if you we got our potential energy as minus 2.3 into 10 to the power minus 18 joule. If you divide it by 1.6 into 10 to the power minus 19, you get it into electron volts. So this comes at minus 14 electron volts. Okay. Next, we're given we have to find the kinetic energy of a proton that has, this is a correction, that has accelerated from rest through a potential difference of this. Okay, so we have to calculate the kinetic energy. So you know the change in potential energy. Okay, so the change in potential energy, there is 5,000 volt potential difference. So the change in potential energy will be equal to change in kinetic energy. Okay, so change in potential energy is 5,000. Delta U is equal to Q into delta V. Okay, so what is delta V? Protons. So Q is nothing but E. So this is E delta V. Okay, so it's equal to delta KE. So, 5,000 into this charge. This is 1.6 into 10 to the power minus 19. So delta KE comes as, so this you can see that this is not, if you solve this, you get into joule. Simply, you can also say that this is nothing but 1 electron volt. So answer is 5,000 electron volts, or you can write as 5 keV, kilo electron volts. Okay. 5 kilo electron volts. This is your energy, kinetic energy that comes out when a proton moves through this much potential difference. So thank you for watching this video. If you like our content, please subscribe to our channel to learn more about physics.